Hello everyone, welcome to lecture 4 of CIN635, and this week we shall be looking at mobile computing through telephony. This slide presents the history of telephony. In 1876, the first telephone system was basically developed by Alexander Graham Bell. In 1892, Stroger switch installed as first automatic telephone exchange. In 1960, electronic switching system ESS developed by AT&T. In 1962, carrier system went digital. In 1960s and 1970s, stored program telephone exchanges. In 1980s, wireless telephony emerged. In 1990s, mobile telephony flourished commercially across the world. Telephony is a field of technology involving the development, application, and deployment of telecommunication services for the purpose of electronic transmission of voice, fax, or data between distant parties. We must take note that telephony technology has been around since 1800s, in different forms, that is. What we are using now is vastly different from the early days and very much advanced. Our phones these days are able to do much more than a normal phone, especially taking into consideration the aspects of computing processing capabilities. A public switched telephone network is a combination of telephone networks used worldwide, including telephone lines, fiber optic cables, switching centers, cellular networks, satellites, and cable systems. A PSTN lets users make landline telephone calls to one another. PSTN, or public switched telephone networks, are normal telephone systems, which are also called end office or local access tandem. A PSTN lets users make landline telephone calls to one another, as mentioned earlier. A PSTN is made up of switches at centralized points on a network that function as nodes to enable communication between 2 points on the network. A PSTN is made up of 3 categories of nodes, and these are local, transit, and international. Now, local exchanges is basically subscriber connection, example, telecom. Transit, it switch traffic between and within different geographical areas, example, calls between different subscribers. And locally, international exchanges switch traffic to telecommunication networks in foreign countries and other distant networks, that is all international calls. Last mile communication, a physical wire, also known as local loop, that is laid from local exchange to the device at subscriber premises. Example, imagine a telecom line from a post running into your house. That is an example of last mile. Multiple access procedures. In PSTN, a separate wire is used to connect the subscriber telephone with the switch. Multiple users can have speech communication at the same time without causing any interference to each other. Unless simultaneous access is controlled, a collision can occur. Collisions are often undesirable. To avoid collisions and undesirable conditions, multiplexing is used. There are 4 types of multiplexers. One is FDMA, frequency division multiple access. Second one is time division multiple access, TDMA. Third one is code division multiple access, CDMA. And the last one that we have is space division multiple access, abbreviated as SDMA. First of all, let's have a look at FDMA. FDMA is one of the common multiplexing procedures. The available frequency band is divided into channels of equal bandwidth so that each communication is carried on a different frequency. FDMA was used in all first-generation analog mobile networks. TDMA. TDMA is more expensive technique than FDMA. It needs precise synchronization between transmitter and receiver. It's used in digital mobile communication. Whole frequency bandwidth is divided into subbands using FDMA techniques. GSM uses a combination of both FDMA and TDMA. Code Division Multiplexers, CDMA. It is also known as bandwidth system, a broadband system rather. What is a broadband? Broadband is a technique of wide bandwidth data over high-speed internet connection, a minimum of 25 megabits per second download and 3 megabits per second upload speeds. Now, CDMA uses spread spectrum technique. Spread spectrum is a form of wireless communication in which the frequency of the transmitted signal is deliberately varied. All subscribers in a cell uses the same frequency band simultaneously. To separate the signals in CDMA, each subscriber is assigned an orthogonal code called a chip. Space Division Multiplexers, SDMA. It is a technique where we use different parts of the space for multiplexing. It makes use of space effectively. It uses different parts of space for multiplexing. Used in radio transmission and more useful in satellite communications to optimize the use of radio spectrum by using directional properties of antennas. In SDMA, antennas are highly bidirectional while allowing duplicate frequencies to be used at the same time for multiple surface zones on Earth. SDMA requires careful choice of zones for each transmitter and also requires precise antenna alignment. Satellite communication systems. Communication satellites are commonly used for mobile phone signals, weather tracking, or broadcasting television programs. Communication satellites are artificial satellites that relay receive signals from an Earth station and then retransmits the signal to the other Earth stations. A properly designed satellite antenna will concentrate most of the transmitter power within a designated area using space division multiplexing. Every communication satellite involves the transmission of information from an originating ground station to the satellite, followed by a retransmission of the ground from satellite back to the ground called the uplink and the downlink respectively. Hence, the satellite must have a receiver with receive antenna and a transmitter with transmit antennas. Refer to the illustration in the slide. Satellite communications occurs as such. A satellite receives data from a transmitting ground station and processes it. This is also called as uplink. And then it sends it over to the receiving ground station. This is also called as downlink. There are three types of satellites, each with its own purpose. The satellites include LEO, low Earth orbit, MEO, medium Earth orbit, and geostationary satellites, also abbreviated as GEO. First of all, let's have a look at low Earth orbit satellite. A low Earth orbit satellite, it typically orbits around the Earth about 500 to 1,500 kilometers above the surface. LEO satellites don't stay in fixed position relative to the surface and are only visible for 15 to 20 minutes each pass. A network of LEO satellites is necessary for GEO satellites to be useful. LEO satellites are only visible from within a radius roughly about 1,000 kilometers from the subsatellite point. Subsatellite point is a point of intersection of Earth's surface with a straight line from the satellite to the center of the Earth. Let's have a look at some of the advantages and disadvantages of LEO. Advantages may include a LEO satellite's proximity to Earth compared to a GEO satellite gives it a better signal strength and less of a time delay, which makes it better for point-to-point communication. A LEO satellite's smaller area of coverage is less of a waste of bandwidth. The disadvantages of LEO may include a network of LEO satellites is needed, which can be costly. LEO satellites have to compensate for Doppler shifts caused by their relative movement. Moreover, atmospheric drag affects LEO satellites, causing gradual orbital deterioration. Next up, let's have a look at MEO, Medium Earth Orbit Satellite. A MEO satellite is in orbit between 8,000 kilometer and 18,000 kilometer above the Earth's surface. MEO satellites are similar to LEO satellites in functionality. MEO satellites are visible for much longer periods of time than LEO satellites, usually between 2 to 8 hours. MEO satellites have a larger coverage area than LEO satellites. The most common use of satellites in this region is for navigation, such as GPS, communication satellites that cover the North and the South Pole. Moreover, let's have a look at the advantages and disadvantages of MEO. Advantage: a MEO satellite's longer duration of visibility and wider footprint means fewer satellites are needed in a MEO network than a LEO network. Disadvantage: a MEO satellite's distance gives it a longer time delay and weaker signal than a MEO satellite, though not as bad as a GEO satellite. Moving on to explore GEO satellites. GEO, geostationary Earth orbit, or geosynchronous Earth orbit, they could be called either of it. These satellites are in orbit 35,863 kilometers, approximately 36,000 kilometers above the Earth's surface along the equator. Objects in geostationary orbit revolve around the Earth at the same speed as the Earth rotates. This means geosatellites remain in the same position relative to the surface of Earth. In geostationary satellite, the orbit of the artificial satellite is as such that the orbital speed of the satellite is same as the speed of Earth's rotation. Though the satellite is moving at a high speed from Earth, it will always appear to be stationary. This is a reason for calling it as geostationary. The GEO satellite could view approximately 42% of Earth. Therefore, a system of 3 geostationary satellites with the ability to relay messages from one GEO to another could interconnect virtually all of the Earth except for the polar regions. To look at the advantages and disadvantages of GEO. First of all, the advantage: a GEO satellite's distance from Earth gives it a very large coverage area, almost a third to a fourth of Earth's surface. Moreover, geosatellites have a 24-hour view of a particular area. These factors make it ideal for satellite broadcasts and other multi-point applications. Disadvantage: a geosatellite's distance also causes it to have both comparatively weak signal and a time delay in the signal, which is bad for point-to-point communication. Moreover, geosatellites centered above the equator have difficulty broadcasting signals to near polar regions. To compare between LEO versus MEO and GEO, so if you look at the satellite height, the very first parameter, so LEO is close to about 500 to 1,500 kilometers from Earth. MEO is close to about 5,000 to 12,000 kilometers, while GEO is close to about approximately 36,000 kilometers from Earth. The orbital period: LEO takes close to about 10 to 40 minutes to rotate the Earth. MEO takes about 2 to 8 hours, while GEO takes a full 24 hours a day. Number of satellites currently that exists to complete the entire or view the entire Earth: LEO close to about 40 to 80 satellites, MEO 80 to 20 depending on the size, and GEO is 3, except for the polar regions. Satellite life: LEO is short, MEO and GEO, they are quite long. Number of hands-off: LEO is high since it needs to communicate with all the servers to cover the entire Earth. MEO is low and GEO is least or none. Gateway costs: LEO and MEO are relatively expensive while GEO is cheap. Propagation loss: LEO is least, MEO is high, GEO is highest, reason being because of its distance from the Earth. This completes our lecture for this particular week. Thank you, everyone.